Hi everyone, we are here to introduce our project Brain Controlled Assistive System. Here is our team, we are a group of 4 members. Every bedridden patient in the society, especially the paralyzed patient, requires help from others. Sometimes even the relatives fail to reach out to the emergency need of the patient. These patients are unable to adjust the position of the bed when they felt uncomfortable. Resting in the same position may cause bed sores and pressure ulcers. Moreover, if the patient wishes to call a person, it is really difficult for them to do so. If they are not in the hospital, continuous monitoring of the patient is also not done properly. These are some of the problems faced by the bedridden patient, and our objective is to provide a better and efficient solution to these problems by utilizing brain-computer interface technology. Brain-computer interface acquires brain signal, analyze them and translate them into commands. The main goal of BCA is to help people disabled by neuromuscular disorders. Let's move on to the working of the project. There will be a sensor placed on the forehead of the patient. This sensor can measure brain waves and send to the module for processing. After processing the signal, control signal are given for different applications based on the commands given by the user through brain waves. Along with this, patient can call for help by sending messages to relatives using GPRS module. This is the block diagram of our project. We are using NeuroSky Mindwave mobile to sensor for capturing brainwaves. The sensor can measure EEG signal, attention level and meditation level. And the sensor send data to the Arduino using HC05 Bluetooth module according to the NeuroSky communication protocol. Along with this, a pulse rate sensor measures the pulse rate and sent to the Arduino for processing. After removing the noise and processing the signal, control signal is given for different application based on the input given by the user. SIM 800L module is provided to send messages to relatives when the patient need any help and to send alert messages when the pulse rate is not in the recommended range. Control signal is given to relay module for adjusting the bed position and for controlling light and fan. IR transmitter is used for controlling the devices work on the IR protocol. DF player mini module is used to give voiceover when the patient gives any command. LED array is used to indicate the attention level and to indicate the count of the eye blink. The Mindwave Mobile 2 sensor consists of an ear clip and a sensor arm. The headset's reference and the ground electrodes are on the ear clip, and the EEG electrode is on the sensor arm resting on the forehead above the eye, which is called the FP1 position. Movement of the eyes and the eyeball causes a change in the potential in the electrodes near the eye at FP1 position. Eye blink produces high amplitude signal that can be many times greater than the amplitude of the EEG signal. Change in this potential of the electrodes is measured by the sensor. Eye blink strength is obtained as time series 16-bit raw brainwave data from the sensor. EEG signal received from the sensor contains noise and it is reduced by applying a threshold. After reducing the noise and plotting the signal, eye blink can be visualized as crest and trough. Crest is formed during the closing of the eyelid and the trough is formed when the eyelid is open. Difference between the data receiving time of the positive and negative peaks gives the time period of the eye blink. For normal eye blink, time period is less than 200 milliseconds, and for intentional eye blink, time period is greater than 500 milliseconds. The algorithm we have developed utilizes this property of the signal to distinguish between normal and intentional eye blink. Patient can give commands using the strength and count of the eye blink. When module is connected with the Mindwave sensor, green LED turns on and the red LED indicates the attention level is greater than 60%. When attention level is greater than 60%, user can give commands. Array of blue LED indicates the count. When count reaches 5, bed control signal can be given. Blink with a period of 2 seconds can be given to adjust bed in foulest position.
to initialize the bed control signal.
Blink with a period of 3 seconds can be given to adjust bed in raising knee position.
Raising knee position.
When count reaches 6, module is ready to initialize TV control signal.
Ready to
After
initialize
TV
the
control
TV
signal is
control
initialized,
signal.
blink with a period of 2 seconds can be given to turning on TV.
Turning on TV.
If TV is on, blink with a period of 2 and 3 seconds can be given for changing channels.
Ready to initialize the TV control signal. Turning off TV.
Similarly, other devices are controlled using various blink counts and strength. Here we have discussed a system that acts as an assistance to the bedridden patient. In the future, by using more accurate ECG sensor and brainwave data, health status of the patient can be monitored more accurately. And with the help of more efficient brainwave sensor, patient can control devices just by thinking about it. It can be implemented by machine learning.